I am going to, let's reduce it a little here, for 8, 2 parabolas. Okay. God bless you. Squared plus bx plus c. X equals ay squared plus by plus c. Or, I'll write this so you can see them better. Y equals a x minus h. That's an h. It's supposed to be an h. Squared plus k. X equals a y minus k squared plus h. Okay, bunch of little formulas with it. Well, these top two are for parabolas that open up or open down. Normal parabolas, and most of the things we do will actually be with those two. One of the examples I'm planning to do will be one of these where it's x equals, and you see the y is squared in these. Those are the ones that open to the right or to the left. Those open sideways. So they go one direction or the other. And that's how you can tell for a parabola. And you're used to seeing this kind where it's y equals in a normal quadratic. You know, like 5x squared plus 7x minus 10 or something like that. You're used to that. So those are the things we'll start with. But what you're going to be doing is changing it into that format and graphing it. That's the things that we're going to be doing in this section. So it's really two things major. We're going to be changing the format, and we're also going to be graphing it. But let's talk about what makes a parabola. And what I want you to do here in this paper is go to about the midway part of it, actually a little more. I want you to make a graph in here. We'll leave a little space in the bottom. And go a little bit more than halfway, maybe. Okay, so set up a nice big, the whole rest of the area is a nice big graph here. And then let's go, I'm going to go up to, we'll go to about here. Yeah, really here. This point that I'm going to right now is 2 and 3. X is 2, no, X is 3 and Y is 2. Okay? You guys need to focus and write this down. I want you to see you writing. Okay? So I'm going to go here to this point. And then I want to go 1, 2, 3, 4. 1, 2, 3, 4. So this point is 2 and 3. This point is -1 and 2. To make sure you get the right ones that I want you to be at. Enlarge that. This point is 3, 4, 5, 6, 7. 7 and 3. Ooh. Okay. I actually meant, now that you got those in there, the next part will be easy, because I actually meant for this to go be a little farther up. So just move that up 2, and move this one up 2, but not the middle one. Not the middle one. Now, take this and go out like that. Take this arm and go out like that way. And once you did that, we no longer need these points, so just cross them out. Those were really just referenced to help us get to where we can have the approximate shape of a parabola. Given my skill in any type of drawing, this misshapen parabola is actually probably pretty good for me. So just recognize that's meant to be a parabola. Okay. Now, this right here is called the vertex. That particular point is the vertex, and I'm going to put H and K. Remember up here in this form, there's an H in here and there's a K in here. And if it was going the other way, there's an H and K, they're just in different places. This vertex, the point of the parabola, the H is the X value and the K is the Y value. So if I had a number here, like this one, it would be -2, X minus 2. And then that 3 would be here. So with just that, you can fill out part of the equation. Okay. Now, there's a couple of other things to know about. I had you put those points because I want to draw a line there and put a point in the middle. That point is called the focus point. And on the opposite side of the vertex, like you see this is like 2 units to get to that. If I go the other way, then this line here, or it just happens to be y equals 0, is called the directrix. So we have a focus and we have a directrix. Now, what's up with this is that the reason why a parabola exists is because at every point on it, like if I have a point here, there's a little line that you can draw from the focus to that point. That is exactly the same distance as if you went down to the directrix at a right angle. This distance and this distance have to be equal. So if this point were farther up, this line would be longer, and then the dropping line down here would be longer too, and they would match each other. So it's sort of like you have the same amount of string connecting them that gets either shorter at the same time or longer at the same time, and it forces it to go out in a curve or to go up in a curve on one way or the other. Now, you don't have to know that as far as I'm not going to test you on that, but just for you to understand, that's why a parabola exists. The definition of it is that every point along there is the same distance from the focus as it is from the directrix. Okay? Now, having said that, it's not really going to affect what we're going to do. We're going to be finding out what the focus is, finding out what the vertex is, writing the equation of this directrix. This line here is called the latus rectum. Funny sounding name, but it's a Latin one. So they sometimes throw a Latin thing in, and it sounds weird in English. That's what they call it. So that number determines how far out you go or how close you go. If it's a small number, it means the parabola is going to go up like this. You're going to have a really, really skinny, thin parabola. And if this number, if this line is bigger and longer, you're going to have a really wide open parabola. You'll have to give me that number, and there's a way to figure it here. In fact, we'll go over a couple of those. One other thing I need to show you on this one, and that's an axis of symmetry. An axis of symmetry is the line that goes through it that it rotates around. Think about a drinking cup. I have only my soda can. Oh, this would work. If I drew a line straight through this, and then I could rotate this around, that line would make this, will allow this to rotate perfectly. If the line was one way or the other, it would like rotate this way. But the line that goes right through the middle of it is the axis of symmetry. And that's what this is. If I'd drawn it better, it would be obvious to see that, you know, this should be out a little further. But then it's almost like they could flip over, or if it was a cup, it would just like rotate around that line. That axis of symmetry, write it here, axis of symmetry is, this is a vertical line, so it's x equals, and it's x equals that h, whatever that number is. So you need to know it's x equals h. You find the vertex by finding the point x, the x and the y of the point. The latus rectum, you figure that out by doing the absolute value of 1 over a. I will show you how to find a. Here it is, actually. You get the a here or over here. And we'll use it later to get that. And the focus point has a special way of getting that. It's h k plus 1 over 4a. That's a pretty weird little formula. Right now, just write it down, and we'll use it the next couple of times so you see how to use it. The directrix, well, first write that down, and then take a look down here at the directrix. I specifically wrote equation after first writing it, because you have to find the equation. Remember I said it's a line down here. Well, this line going this way is the axis of symmetry. This line going this way is the directrix. But when it's going this way, it's a line of y equals something. It's y equals this, but minus. K minus 1 over 4. So that's another formula to know. 1, 2, 3, 4, and finding the vertex is 5 different things that we have to find. So that makes this a pretty complicated thing to do. So what we're going to do is use that handout. Oh, where is that? I gave you one like this for parabolas with a little graph on the bottom. Please take it out, and we're going to go through the steps to do this kind of graphing for one of these. So I'm going to give you, what we're going to do is we're going to write up here first, because I want to do something. We're going to be finding the vertex form. We're going to find the coordinates of the vertex, the coordinates of the focus, axis of symmetry, equation of the directrix, all those things I went through. Here is the one for the lattice rectum, and in between we're going to put about the direction of where it opens. That's the easiest thing of all of these. But let's start over here first. I'm going to write y equals negative 2x squared minus 20, minus 20x minus 49. So please write that out on there. I wrote a little meter on this one, so you can see it. What we're going to do first is we're going to change this into the standard form, the vertex form. So I'm going to go over and show you how to do that. What I'll do on the test is I'll have you do this once or two times probably. I'll have you probably do it one time without a coefficient here, and then one time with the coefficient. And then I will give you the standard form for this. So there'll be a separate problem in order to graph this. All right. So, I want to complete the square, but I have a negative 2 here. So I'm going to do this. Okay, now let me explain that, because this is a little different from what I did on those other problems when we started class. The complete the square part is now going to be the same, but this negative 49, I did not add 49 over to this side. That's because it's not equal to 0. It's equal to y. And the right form that we need for the parabola requires us to do everything on this side. What that means is when I add something in here, I'll have to subtract it over here so that it keeps that side balanced. And you can do that. You've learned before that you can add on both sides of an equation, or you can subtract on both sides of an equation. Well, the fact is you don't have to if you still keep one side balanced. So if you add on one side and subtract on that same side, the same thing, then you're keeping it balanced. Just make it look different. So we're going to make it look the way we want, but we're going to add and subtract the same thing. So this part, now I can do the completing of the square for this. And to do that, I take this, that the c, the number I need here, c, is equal to the b over 2 squared, which is 5 squared, which is 25. So I'm going to put a 25 in here. And I'll rewrite that to show it so that on mine you can see step by step what's happening. So it's going to be plus 25 minus 49. Well, if I'm going to add 25 here, you would think that I should subtract 25, but there's a problem with that. This 25 is not really a 25 because of this. Because it's inside the parentheses, this 2 has to be applied to it, so it's really a 50. And because that's a negative, it's really a negative 50. By writing a 25 in here, I'm subtracting 50 from this side of the equation. I'm doing a negative 25. That's because of that negative in the 2. So over here, that means if this is really a minus 50, that means I have to do plus 50 here to balance it. I have to balance that out, put a plus 50. For the next part now, I want to make that part a square. Because I did this work with the c, I was able to get the perfect number that allows this to be a perfect square. Write it in yourself what you think it should be. I've given you enough info. I want you to do it. In about 10 seconds I will write it too, but I want you to see if you can get it right first. Based on what I told you, think about what number goes inside the square. Based on this info here. If you put plus 5, you are correct. Anything else would be wrong. You take this number and you take half of it and put it in there, plus the same sign, whatever it was. If you didn't remember that, make a little note on your paper or something to remind yourself to memorize that, okay? Because that's one of the key things to this. That's how you get the right square thing. In fact, there's a number of steps in here as we do the steps, and you think to yourself, I'm not going to remember that. Write a note to yourself to help you go back and look at it later so you can focus on it and memorize it. So you can remember it if you know you're supposed to and if you practice it. Over here, 50 minus 49 looks like a plus 1. This is the standard form. So one of the questions I will give you on the test will be similar to that. Might not have the same numbers. This is about the most complicated one you can get because you're taking out a common factor that involves a number and a negative. But it was a good one for us to see because you could see those steps we were doing. But now we have this in the form we can graph it with. So take that and write it up here. A separate question on the test will be doing this. You're going to find the different things and you're going to graph the parabola. On the test, I actually will count this as worth 2 questions because there's so much work to it. So you basically deserve the credit for getting more points for getting it right and working on it. So another reason to make sure you know it because you know it's going to be worth a lot. So what we're going to do is find the vertex. And remember the vertex is h and k, or an easier way to think of it is x and y. It's a point, but that point, x and y, it's the h that's in here, and it's the k that's in here. But you have to remember something else now. The x value in here, it's x minus that value. So I have to change the sign, and the reason because the formula is that it's x minus whatever the h is. So I'm going to put in parentheses to show, for that to be a minus, this would have to be a negative 5 in order to make it resulting in plus. So the reason it's plus is because it's supposed to be negative, which sounds really weird, but it's because there's 2 negatives. And when you take the number out, you have to revert it back to the first negative that it had. So that's the vertex. Right now, let's go on down and let's graph that and show where negative 5 and 1 would be. Negative 1, negative 2, negative 3, negative 4, negative 5, and up 1. So now we know where the vertex is. So it could be graphed going up like this, it could go down. It won't go sideways because that would be y equals, or x equals a y squared. This one's not. Okay, now for the focus. Well, when I did this paper, I did this for a reason. To find the focus, you need to do this little thing. Okay? So I'm going to write that over here as h and k plus 1 over 4a. To remind myself, the h part's easy, it's going to be negative 5. It's this part that we have to figure out. So what we need to do is figure out what a is. Well, a is pretty easy because it's that number in front, either here or here. A is negative 2. The formula calls 1 over 4a. So if it's 1 over 4a, we need to do 1 over 4 negative 2. So we need to put that a in there. That's 1 over negative 8. Oh boy, I have to deal with a fraction in there. Okay. So this 1 over 4a, reduce it because I got opposite sides of the paper. 1 over 4a is actually 1 over negative 8, or negative 1/8. So the k is 1. I'm going to do 1 minus 1/8. See how I figured that out? In fact, I'll write that out, that I'm supposed to do k minus 1 over 4a. 4a, that's 1 over negative 8, so it's 1 minus 1/8. I need to write it more clearly here. If you're at 1 and you take away 1/8, you've got 7/8 left over. So that's 7 over 8. So this is what, I guess I'll write that this is k is equal to that, k is equal to that, so this is what k is. Let's come back up here and write it in for the k. 7 over 8. Well, that means since this line is 1, if I go out to negative 5 and go up here, I can barely even put that. The good news for you is that when I do this on the test, I'm not going to require you to put the focus on there. Okay? Most of the time it's so close and so tiny to see the difference that it's immaterial. You could put it on there, but you can't see it really and I can't see it. So I'm not even going to make you put it on there. But I am going to make you get this number right. So you have to put 7/8 there in this case. Back here, equation of symmetry. Remember this equation, the axis of symmetry is the line that it revolves around. That's the same as the x value of the vertex. Same as the x value of the vertex. So I'm just going to say that it's x equals -5. So the axis of symmetry, if I were to graph it, would be a line going up like this. But I won't require that to be graphed. You might find it helpful though. Okay. The equation of the directs is y equals k minus 1 over 4a. Oh, so it's just like this except it's a minus. So let's figure that out. K equals, y equals k minus 1 over 4a. Y equals 1 minus 1 over 4 times -8. That's what we did here. -2, and then it becomes 1 over -8. Y equals 1 minus 1 over -8. Oh, we've got two negatives that will cross out. Y equals 1 plus 1/8, which is simply 1 1/8. That is what y is equal to, so we write it here. Y equals 1 1/8. Okay, so for those still copying that down, I'll leave that for a second until you get that down. So I put in the -2, multiplied by the 4, got a -8. Those cancel out to make it plus, so it's 1 plus 1/8, that's just 1 1/8. Back here, I told you this is the vertex, and the focus is a certain distance above it, and the equation of the directrix is the same distance going the other way. That's what happened here. The focus had k plus 1 over 4a, and the directrix is k minus 1 over 4a. Plus sends you one way, minus sends you the other. And so that plus or minus 1 over 4a is what allows you to separate from the vertex to go those distances. Now, the last thing is direction of the opening of the parabola. This is the easiest possible thing that you should be able to get. There's no reason anybody should ever get this one wrong. If the parabola is positive, it's opening up. If the parabola is negative, it's opening down. Looks like a negative to me. Up or down, positive or negative, that should not be something you ever get wrong. Everything else, if you get everything else, you should be able to put it up or down correctly. All right, because that one's not even hard to remember. Make sure you remember it. You got to get the other ones right too. But latus rectum, last one here, 1 over a. A is that -2, so it's the absolute value of 1 over -2, or -1/2. But because it's absolute value, it's a positive 1/2. What that means is that from the vertex, or from the focus is there, that means we have a very small 1/2 and 1/2. So, which is sort of hard to determine. The parabola is going to go something like this. It's not on here, but I'm going to tell you the key to graphing it is just take a number or two on one of the sides and just sort of see where the point is. So, this is -5. I'm going to go down to say -3. If x is -3, let's put -3 here and see what happens, and it'll give us a point for it. I've got space here, so I'm going to do that. Y equals -2, -3 plus 5 squared plus 1. So what I did, because I want the x to be -3, I'm going to put that into x. I want to find out what y you get if we go down to -3. So y equals -2, 5 minus 3 is 2, so it's 2 squared plus 1. That's 4. 4 times 2 is 8, but it's -8. Y equals -8 plus 1. Y equals -7. Oh, now interesting. By doing that point, I see I'm at -3 and 2, 4, 6, 7. Well, I started drawing this as if I might be going up because I'm so used to doing that. I've done almost all of them like that all the time. But this is forcing me to go down. I even said down here. Now I'm forced to go down because I pick a point and realize that the parabola's got to go through that point. And because these are symmetrical with an axis of symmetry, I can just go on the other side and draw it down through that. So get that in there. Make sure you show using the -3. So I'll say x equals -3. And that results in that -y, so we have -3, -7 as a point on the graph. And now that forces me to draw it going down. Once you get that done, now you've completed this. So let's review this part. Come back to it. Those still copying it, give me another moment to get that in there. Okay. I did this first, where we completed the square and had to deal with the 2 and the negative. That's a separate question, but it leads up here, now in this case, to using that vertex form, to find the vertex, the focus, the axis symmetry, each one of these, using that 1/4a for 2 of them. And then graphing it, finding the vertex, and you don't have to draw, I put that 1/2 there, you don't have to do that. The best way to do it, because it's so small and the focus is so close, you don't really actually need to do it. You just have to be able to find it up here. What you do need to do is plot a point farther down, and that point symmetrically also goes here, so it shows you where to graph it. If I didn't know the -3, -7, I probably would have thought that it was more out like about here. And then that way about the same amount over there. I would have been wrong with about how wide it was. By putting a point here, it forces you to keep it the right thinness or width, however much it is. Okay, so make sure you plot a point for it. Okay, you have a back page on that. Let's do another one of these, and then we're going to move on to the next thing. Let's get one of these. This next one, I'm going to do the same thing where we're going to figure out what the form is here first. I'm going to do this. X equals y squared plus 8y plus 17. So put that there. We're going to need to complete the square. But you notice these are y's. So what, as far as completing the square, we'll still do it with the y's. X equals y squared plus 8y, move the 17 over. C equals something squared. Go ahead and figure that out, please. If you did that right, you had 8/2, which is 4 squared, which is 16. So what I just did here is I showed that it was the 8, because you need to use that same number and divide it by 2, which is 4, and then square it. And you put that 16 with it, but then you subtract the 16 to keep this side even. Okay, complete that part of it here. Write down what should be in that perfect square. Based upon what you've done here now, write what should be in that perfect square. If you did that right, what you did is you just simply took that 8 and divided by 2. X equals y plus 4 squared plus 1. So notice as you're writing it that there's no coefficient out in front. We didn't have to take a number out of both. No coefficient in front. But what is different about this one is the y value that's being squared. That means that this is either going to open this way or it's going to open this way. If it opens to the right, that's because it's positive. If it opens to the left, that's because it's negative. And if you look at this, you can tell right now that it's not a negative. That means that this one, when you graph it, is going to look like this way going to the right. Okay. Coordinates of the vertex. Remember when I wrote at the beginning, where is this one up? At the beginning, I gave you these four formulas. These two are for ones that go up or go down. And then these other two are for the ones that go right or left. That's what this is, so we're going to look at these. Notice that the h and k, h is still the x value, but k is the one that's inside now because it goes with the y. So if I want to know the x value, I'm going to take this one for the x. And the y value will be the inside number, but now it's opposite sign, just like the x was in the last problem. So you have to remember it's opposite sign there for it. Okay. Now, this time for the focus, we also switch that little formula. Watch how I switch it here. H plus 1 over 4a. That 1 over 4a, okay, that's not really a fun thing to work with, but we have to do it. On the last problem, it was that k plus 1 over 4a. Now I'm telling you it's h plus 4 over 4a. The reason it switched was because it's an x equals and a y squared, because it's this type of problem, because it's going that way. As a result, it's the h that has to change, going sideways. So what's a? A is a 1, so I'm going to come over here. A is equal to 1. So h plus 1 over 4a. The h is 1 plus 1 over 4 times 1. 1 plus 1 over 4 is 1 1/4. So this area here, I just worked this out where a is 1, and I know that that x value for the focus is h plus 1 over 4 times a. And then I put 1 in for the h, because that's what that has been already. That was a 1 here. And then the a is equal to 1, so I put it in and I get 1/4. So back up here, that's going to be the x value for the focus. Back up here, the x value of the focus is going to be 1 1/4. And the y value is the k, which is the same normal k that we got from there, minus 4. That is so close to it, again, that's so close to the vertex that we can't graph it. So that's why I'm not requiring you to graph that. You just have to graph the vertex. In fact, let's go back down here and go to 1 and negative 4. Put that spot on there already for the vertex. The axis of symmetry. Well, I always said it was the x value, but you know, if our parabola is looking like this, let me draw it like this. If this is what the parabola looks like, then a line that's going like this, it's not going to like cut it exactly in half. Instead, it's going to be the line going this way. It's horizontal, that means it's the y value. That negative 4, you write y equals negative 4, because it's a vertical line, a y value, y line. For the equation of the directives, just do the opposite here. Minus, 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 minus. So if it was 1 minus 1/4, it would be 3/4. So that's all it is. It's x equals 3/4. Okay, for f, write down the direction of the parabola. Think about this, that if it's a positive parabola, it opens to the right. Negative parabola opens to the left. This one's positive, so we're going to the right. Latus rectum is 1 over a, but now we know that the a was 1. So 1 over 1 is just 1. Okay. So those are the numbers that are correct for all of those parts. Now to graph it, We can use some of those parts, but what I want to do is I want to do a couple of numbers 4 away from it. So I'm here for this vertex, I'm at 1. Let's go 2 away and let's go to positive 3. Okay, actually I don't know where the point will be, so I shouldn't put that in there. So let's take the formula here and let's put in a positive 3. Okay. So x equals y plus 4 squared plus 1. I'm going to put a 3 in there for, oh, now I've got a problem. If I put a 3 in there for the x, then I'm going to have to like take the square root of it and subtract 1 and then subtract 4. This looks like a mess. Instead, what I can do is, remember, putting a number in for x doesn't really help me do this stuff. So it's a y that I need to put in. So if I come up here to say negative 2, then if this is opening this way, there should be a place along here where I get a point. And then I'll know which way how to draw the line. And then it's on the opposite side because of the axis symmetry. So let's use negative 2 to figure out what the x value would be. I would put a negative 2 in here. X equals 2 squared plus 1. 4 plus 1 is equal to 5. So we're going to notice that because I use negative 2, I get the point negative 2 and 5. 1, 2, 3, 1, 2, 3, 4, 5. So from the vertex, we go through that line, and then we draw another one in the opposite of it, and you're going to draw that. And now you've wrapped that parabola. So this point comes from my plugging in here, that negative 2. For the y, and then